Good morning, everyone. Kingsley, I think we can start at 10:10. I don't have power to chase people today. If they don't want to join, it's okay. So please, let's just start at 10:10.
All right, no problem. Good morning. Uh, the guy that's supposed to handle the first part is not here yet, so I'm still waiting for him. Hello, Fatima. He said he's waiting to be admitted in. Good morning, everyone. Welcome to today's office hour. Without taking much of your time, I would like to introduce the first speaker for today, Uneku Ejiga. He will be taking us through AWS serverless building and using serverless infrastructure. So the floor is yours, Uneku. Hello, Uneku, can you hear me, please?
Hi, yeah, I can. Sorry, please, I sent you a message. Could you just quickly check it out and then I'll get back to you, please?
Okay, so while we wait for him to pick up and join us, he just a little emergency. He will sort that out in a few minutes. You're welcome to today's class again. This is the not already end actually. We still have one more day. So we are currently on week 8 of our AWS expedition. We have roughly 4 more weeks, if I believe, 8, 9, 10, 11, 12, and we'll be done. So we're close to the end already. Um, as always, I would like us to share if we have any challenges we've encountered so far, any problems you've had during the course of the challenge, either for this week or for last week. The floor is open for a few minutes. Do you have any challenges you've encountered? Do you have any questions? Please feel free to unmute your mic and contribute. Did anyone carry out the challenge this week? No one. Really? Okay. Uh, Chibuzo Uzuaru. Okay, this is your first time joining the office hour, yeah? You just joined the group of recent, I believe.
Yes, actually, I did. Yeah, just recently.
Okay, all right. You're welcome.
Right. Thank
Uh,
you.
this, this is our weekly office hour where we talk about our progress for the week. Currently, we have a challenge, the AWS Expedition challenge, where we.
Hello?
Yeah, okay, just give me
Um,
2 minutes,
so
please.
Kingsley.
Yeah, I can hear you. Give me just 2 minutes. I'll
Yeah,
hand over to you.
okay, now I'm ready now. Sorry, I had to just make some um slight adjustments, please.
Okay. 1 minute, I'll hand over to you. Let me answer. Let me finish up with Chibuzo.
Okay, go on, go on.
Yeah, so Chibuzo, we're currently on the AWS Expedition Challenge. It's a 12-week program where we take one AWS service per week and we go through. We have hands-on labs from AWS directly, AWS workshops, and we'll probably be done in the next few weeks. But we'll be starting again for a new cohort or a new batch rather, starting with week 1. So probably if you're interested, you can join that. All right, Uneku, over to you.
All right, thank you very much. Hi everyone, good morning. My name is Uneku, and today we'll be talking about AWS serverless service. I don't know if you can, everyone can hear me. So, um, AWS Serverless. I believe at the time people hear the word serverless, people begin to like try to understand what exactly do they mean by serverless. Does it mean like the application is run without a compute or run without anything under it? But I would just like us to I would just like to like further explain that when you hear the term serverless, it just means it's like a type of application that runs without you having to like fine. So with AWS as a service, it provides us a set of tools that we can use to run our applications in a pay-as-you-go model without the use of arranging and setting up servers and the rest. All you just do is you set up your um you set your code, you program your other infrastructure, put them in line with the logic, and you run it or you deploy it, and then it automatically kicks in as you enter. So in AWS, there's also other serverless applications or serverless computes that AWS provides. There's AWS Lambda, there's AWS Step Functions, there's the AWS Serverless Application Model, that's the SAM model, which is an open source framework that we can use for defining our serverless functions, and think of it like a script or like a model that which you can use to organize or create your serverless um, applications and the rest. And also some of the services in AWS uses the serverless functions under it. For example, AWS Event Bridge. Event Bridge is a pub sub bus service that can connect two or more services together. Then we also have X-Ray, CloudWatch, Cognito, and some other services that use serverless under the hood. And I think also DynamoDB and Gateway too, but that's for like a future research. I hope everyone is with me. I hope we're all here together. Hello? All right, great. So some of the benefits or some of the use cases of AWS's serverless compute, right, is to provide scalability, enable cost efficiency, reduce operational overhead, and also increase time of development. So, like when we say scalability now, it can serverless functions can actually increase their size to handle much larger loads and compute automatically on its own. I do understand there's a bit of a concept of auto scaling in your EC2s, but instead of you setting up auto scaling, serverless compute has the ability to automatically scale up to handle close to millions and millions of requests per second. And then in terms of cost efficiency, you only pay for the compute resource that was consumed during the execution of your code or the execution of your function. So you're not going to be charged for just having the function, but you'll be charged for how long the function runs, maybe the amount of storage the function used, and also maybe their memory and other things that had to be generated for your function to be used. Then for reduced operational overhead and increased speed of application development. So instead of you having to settle down and be creating your code, be creating compute, be creating this and that, all, you can just simply carry your code, send it to an AWS Lambda, for example, Lambda, test it and deploy it, and then your code basically is available for use or for call. So instead of setting up compute, setting up VPCs, this, that, and the rest, you can just have everything set once, and anytime you need to use that particular code, you just call the function or just set up the function, and we're good to go. So some other applications and some other uses of serverless includes like IoT devices or applications, API usage, data processing or data streaming. Like you can use it to effectively like stream your data through a particular set of actions or particular set of codes. So the offerings have actually been developed with a strong focus of ease of use. So it was actually made to help developers to quickly and rapidly deploy their applications. And it has evolved to use other services, including maybe containerized apps, a messaging or a messaging or a pub sub application like Kafka and the rest. Not to replace Kafka, but it can also serve like a pub sub application. And you can also, make use of it with other frameworks and the rest. It supports a wide variety of languages and can be custom made or custom used. So with that out of the way, I'm sorry I don't have much to say, and I don't really have the slides, but I'm sure at the end of the meeting, I will send the link to the GitHub repo and we can make do of that. So if you don't mind, we can proceed to a mini hands-on project that I had created to present today, if that's fine. So let me share my screen and we'll talk more when the when the screen is showing up now. Yeah, just a moment. Please do let me know when my screen is showing up and it's when my screen is available to see. Hope everyone can see my screen. Can we all see my screen? All right, great. So I don't know. We're in week 12, and this was the labs for the week,
Yes.
and it looks a little bit overwhelming for some people, right? Especially with the use of multiple lambda functions and lambda step functions, especially with SNS and SQS. And as you can see, I may even cognito that I mentioned. So basically, this is like a diagrammatical representation of how we can set up and use serverless application to run or do other actions. Like in this case now, we're using the serverless compute provided by AWS, which is AWS Lambda, to update, let's say, the table or some information in the DynamoDB table. And you can see that we also have some step functions under after the lambda and the rest. So just think of the step function as another function that occurs or that is triggered immediately after the main lambda function is called. So maybe like you have a function to go and update the table, right? But you also have these other functions to go and call maybe SNS or go and call maybe SQS and do another action for you. So instead of creating another function again, you have this function that goes to do this or goes to do that. And yeah, like I mentioned, Cognito too. It's another service that uses serverless under it, but we can't see it. It's just but it's just part of knowledge that we know. So the developer or the user, for example, makes a request or makes a call and it goes to API gateway. API gateway communicates to Cognito, ensure it's verified, the user is either signed in or not signed in, and the further actions take place. Then it goes to SQS and SNS, maybe SNS for SQS and then SNS for notification or queuing the services, which now goes to Lambda, and the Lambda now on its own part goes to DynamoDB and update the table. So in this case, we're going to use the put or the patch to update our um, DynamoDB table. So let me just open the repo. Let me just open the repo shortly. Sorry about that. Remind me later. I hope you guys have updated your 2FA because I think any moment from on the 15th, they will block you from using your GitHub account if you did not set up your 2FA. So I thought that instead of using this diagram, I created a much simpler and easier application that we can use. It's still based off this application, but I removed the step functions, SQS, and Cognito for now. We can later on add all these other functions, but for now, we want to just build something simpler and easy for us to just be able to easily grasp, to easily understand how to set up maybe a serverless compute and all those other stuff that we need. So this diagram is just basically on our us here, the developers or maybe a consumer will go to our website and we'll make a sign-in request or maybe a sign-up request, which passes through Amazon API gateway. Then the API from Amazon API calls the Lambda function, and then the Lambda now goes and updates our DynamoDB table. I hope this is not so large and this should be easier for people to grasp and understand. Then I just said, let me put this one here too for our fellow friends that are coming from Azure. It's the same thing, but just from the Azure side. You have the API management, which is equivalent to the gateway, the function apps, the same thing, which is Lambda. Then we'll use Cosmos DB, which is also can serve as the DynamoDB SQL kind of a table. So this project, if you do this project right, you can basically almost run it for free if you are within your free tier limits. I think Lambda still has like 1 million calls per month, and API Gateway 2 also have like I think almost about 1 million free calls per month, and you can basically set this thing up without spending a single cent. but you should watch out for your lambda calls, because if you make too many calls more than the limit, then it starts charging you. I think for every 3 million calls is $1 or thereabout. You may have to do the math, but let's just get to it. So let's get straight to it. So we'll go to the AWS console, and then we will start setting up this infrastructure. And it should be quick, simple, and straightforward. So can you give me a minute? Let me just switch my screen, and then I will this thing. Will continue. Just a minute, please. Let me switch my screen, and we'll continue from there. Let me this thing. Just a minute, please. Where this thing go? Oh God. Where this thing go? Okay. All right. Screen. So somehow, I don't know where the code went too far. Code don't loss, but no problem. We don't.
Try checking your history on if you open VS Code, try checking your history. The last folder.
Oh, it's true. I think I was working on something else before that one. I think I was working on something else before it. All right. Thank you. It was here. I've seen the folder that I put it in. So this is just the front end of our application. It's going to be just a simple page with like a form input that you can use and get inputs from the individuals, from the, let's say, customers or so. You just input your name, your email, phone number, password, and then you click submit. This should fail on first try because we have not set it up, but we can go ahead and continue. So let's go to AWS and set up our infrastructure. If at any point I'm too fast, please drag my attention so that I will slow down, and I'll maybe like re-explain if in case I missed something. So we'll begin from here, or from the gate DynamoDB. We'll start from easy to hard. So this laptop and Python logo is here, which is our code here and on our application. The lambda function is actually written in Python because Python is a more lightweight code, and also we'll be using AWS Boto 3. Boto 3 is AWS Python SDK, in which you can use it to call AWS services. So you can read up about Boto 3. It's just basically their SDK, which you can use and call the resource and then the actions on the resource. We'll get back to this place shortly. So let's go to AWS. And the first thing we're going to do is we're going to create our DynamoDB table. So you can come to the top left, search for DynamoDB, then we'll create our first table here. Let's give it a minute. Let the page load. So this is the DynamoDB dashboard. On the left here, you come to Sorry, my network is a little bit low, so you have to um, bear with me, please, while I load. And then DynamoDB is like a managed SQL or SQL type of a table. You don't need to create the compute or select the type of DB you want. Since it's already managed, you just create what you need to create. So we're going to create a new table, and let's call it Nexa table or Nexa registration table. Let's just call it Nexa table for now. And then, sorry, my screen is not sharing.
Yeah, I just went up. No, I can't see it currently.
Oh, sorry. Uh, Network is not the best here. Sorry. Very, very sorry about that. So let me reshare my screen again. Please do let me know that the screen is showing now, please. Can we see
Yeah, I
the
can see your
create
screen.
table? So thank you. Thank you. So this partition key now. So I believe then database developers, you know that when you're making an SQL or NoSQL table, you know that the partition key is a required place. You can't create a table without having the partition key. So we have to, in this case, we'll just use the email as the partition key. Our sort key is optional. You can leave it empty. Then for our table settings, for now, we'll just leave the table settings on default. Unless you are given like maybe particular specifications to use, like maybe creating it in a particular VPC, the amount of RCUs and WCUs that you need or have, and security groups and all those other stuff, you can come to customize and make some extra customization. You can switch it to on demand or the capacity, read capacity, which is RCU, or write capacity, which is WCU, and other further customization. But for the sake of simplicity, we'll just leave the table as a default settings. Once that's done, you can set your tags. And as usual, don't forget to tag your application so that when you're searching for it in the resource section, you can just simply use the tag and you'll find what you're looking for. So we'll call it Nexa DDB. DDB meaning DynamoDB table. Then we can now go ahead and create the table. So this will take a few minutes. So while this is creating, we can move to the next step. In the next few minutes, we'll come back to this place. And then also you take note of this name because we are going to update the Python code to send requests to this Nexa table instead of to this registration table. Our DB is active, so we can go ahead and move to the next stage. The next stage is to create our lambda function. And the next stage is to create our lambda function. So we'll go to lambda, but in fact, sorry, before we create our lambda function, I trust AWS. There are times that you have to go back, go and create something first before moving to what you need to create. And in this case, we need to create a role for the lambda function. So what we're going to do is we're going to quickly create the IAM role for the lambda function before going to actually create the lambda function. I hope that's fine. I hope we are together. I hope I'm not too fast, and I hope we are together. So yeah. So we are here on the IAM page, and we're going to create a new role for the lambda function. So we're going to click on create role. So the entity is AWS service. So the lambda function is a service offered by AWS. So you click on AWS service, Then in the use case here, we'll look for lambda because we're trying to create a lambda function. And then we'll click next. So this is the add permission role now. We're going to add 2 permissions to the lambda function. One is going to be the DynamoDB full access. Make sure you select Amazon DynamoDB full access. We're giving it full access because we want it to be able to get the DB, list the DB, to basically crawl the DB because we're going to add stuff into the DB and you also have to get the name of the DB. Then we'll also add CloudWatch full access. This CloudWatch, sorry, see my spelling of cloud. So we're going to look for CloudWatch full access. Where is that CloudWatch full access? Okay. Although this one is optional, although CloudWatch is optional, it's also good to have this thing. It's also good to have your logs stored somewhere so that in the case of CloudWatch logs, where is this CloudWatch full access now? It's optional, sure, but it's good to have CloudWatch. Let me see. Am I doing something wrong? I'm coming. Let me get fresh. But it's good to have CloudWatch logs attached to your account because when things go wrong, it's good to refer back to your logs and you'll be able to see the error. Where CloudWatch full access go now? But since it's optional, no problem. We can leave it for now. I will show you in the other one that was created earlier. Then we'll just name this function. Let's say, so we'll just name this row Nexa row. I'm just using a simpler name because we're going to reference the name in the future. We'll just call it one Nexa row. Make sure the permissions are here. I'm not sure why CloudWatch decided not to show today, but voila. We'll click on add new tags. And as always, don't forget to tag your resource. So let's call it Nexa row. And then we'll create the row. Yep. So I think the role has created this registration form row. I'm not sure where this thing went to. So I can see under permissions, you can see CloudWatch full logs. Why it's missing here, I'm not sure. But let's see if we can still attach it now that we have created the row attach policy. Or did they change the name overnight?
I posted the name on the chat. You search under policies.
But anyways, policies. Yeah,
Under
I should be
policies,
under
you see
policy.
AWS. Check the chat. I posted the full name, so just copy and paste it.
Okay, just a moment. Okay, AWS Cloud Formation. No Cloud Formation, CloudWatch, because we're saving the logs of the stuff.
Okay,
I'm
sorry, hold
saving
on.
the logs of the. See CloudWatch full access here. I'm not sure why it did not show under there, but no problem. It's fine. Let's go to. We can now go to Lambda creation. We can now go and finally create. We can now go and create our Lambda function. Just a moment. So basically, the CloudWatch, you can go. Sorry, you can go there and go and read the logs, and you see what happened. So we're here in the Lambda page section. We can click on create function. So we're going to create a new function and we're going to author it from scratch. If you have an existing blueprint that you can use this part. Or if you have a container image that you have, you can select container image. For the name, we're going to use Nexa function. Again, I'm just writing it like this so that it will be easier for us to reference in the front. Then for the runtime, we're going to choose Python runtime. Why we are choosing Python runtime here is because our lambda function here is written in Python. So when the lambda is being created, it will create it with a Python environment so that we can run our Python code with ease. Then for the architecture, leave it as x64. Then for the permission, we're going to use an existing row. So remember when I said we'll have to go and create something before coming back to create this one. This is that part. We'll have to select that permission or that row. And not just Lambda, it happens in some other services too. You may need to go back, create role, create the other thing, then come to the service and now create the service. So we are done with this for now. We can come to advanced settings also, and you can do some other things like code signing, enabling the VPC. Maybe if you want your function to be coming through just from your VPC or be accessible from your VPC, you can enable VPC. But before we leave here, again, we'll put our tags before we go. So we'll call it Nexa. Let's call it llama function, lam func function. And then we'll click create. And just like that, we have our lambda function. It's not complete, but we'll continue from there. So normally you would have something that will trigger your Nexa your lambda function. And like in this case, normally you can have cognito calling our other lambda function that will trigger something else. That means that here will be cognito, which will trigger our function and to go and do something else wherever it is. But we're just going to use a more simplified method for now. And automatically, rather, the API gateway will be here, which we'll call Nexa function. Then we'll now go and update DynamoDB. We'll set that up. But for now, we're just going to go through the code method. So in this lower part now of this function, this is the place that you will impute your lambda function. Let me tell you the secret to this lambda function. Keep your code small or keep your code minimal, because if you have plenty things in your function, it increases the time that is used to create the function. Import the requirements or node modules in JavaScript, but here requirements.txt and all that, and download them, install it, and run it. So that takes much more compute time. So it's best the secret to the lambda is to keep your stuff or keep your code very small or keep your code as minimal as possible. And because many people are going to be calling this function severally, if you can keep your code to a minimal size, it will be able to run it much faster, and it will also scale up to handle millions of people. So this is basically the Python function. We'll be using Boto3. As I said, Boto3 is AWS Python SDK, which you can use to call AWS, call resources in AWS. When this is done, you can see that changes are not deployed, so you can click deploy. It must not be a non-empty zip. Did I say? Okay, I didn't press save. So we can save this and we can run a test here, and you see that you need to update the table and see the table, these details. So I Mr. Kingsley, are we good with time, or I should try and catch up again? Try and catch up more.
If you can, this 10 minutes to 11. So if you could probably explain and probably summarize if possible.
All right. We are almost done here. Or we're basically almost done like this. Our Lambda is already deployed. So last but not the least, we'll go to API gateway and we'll create our API that will call the Lambda function. Sorry, my network not so good. So click on create API, then make sure we click REST API, but the one that doesn't have within a VPC. So click on build, then click our API, REST API, new API. Let's just call it Nexa API. Same thing. Our endpoint type, just leave it as regional, because if you change it to private, you'll be expected to create some other functions and can only run from within the private section. So here we're going to quickly create the resource and the method and enable calls. So from our actions, we'll create a resource. Now this resource name, we'll make sure the name is called register. You have to create this name exactly in line with your function /register, because in our post function, our API endpoint here is called /register. So what we get from API gateway is what we'll put here, and it will now be /register. So create our function, then don't forget enable calls, and then we'll click on create resource. Good. Then we're going to create our method. We're going to create a post method because we're going to post some details to the API endpoint. So since we're using the integration since we're using Lambda function, we're going to integrate Lambda. Make sure the region is in the same region with your Lambda, and then the name the Lambda function is Nexa function. So remember, I say take note of the name because we're going to reference it somewhere else, and then we'll click next. It will ask for your permission to give it permission to use this and use that. And then last but not the least, we need to enable calls. Just leave all these as default. You can enable calls and allow it to this thing. So like this, we are completely done creating all these. Sorry, we're done creating all these resources. We've created the gateway, we've created Lambda, we've created DynamoDB. So what is left for us now is to test our code. So before we test our code, where is the endpoint from API? Great. Once that is done, where is our endpoint from API now? It's supposed to show us our
Try deploying.
deploy. Thank you very much. I forgot to deploy it. Thank you. I forgot to deploy it. So click on actions, then we'll click on deploy. We'll just call this a new stage. We'll just call it test stage. This is just for testing purposes, so you can just leave it as the test. Thank you very much for that reminder. So we now have our deployment, our invoke URL. This is our API gateway endpoint. So once we have this, we can come to our code here, and we have to update this endpoint here with the one that we got from API gateway. And you can see it ends with /register, because it's going to go and call this endpoint. Sorry, it's going to call this URL in the register endpoint, which our register endpoint will now go and call lambda, and we should be good to go. Then also for our table, remember we changed the name to Nexa table, so that it will not be here. It will be on the, it will not be here, sorry, it will be on our lambda. To be on our lambda function, but that's fine. We can still send this information to the registry. It will still be the Nexa function that will trigger the this thing, that will trigger the updating into DynamoDB. Unfortunately, I don't know where CloudWatch lost, but I would have shown you that, okay, this logs is coming from the Nexa function and it's going to the DynamoDB table. And like that, we are here. So we can just refresh the page, click on here and fill in our name. And we'll just use, I'm using just Nexa, Gmail, and the rest, so that when the table updates, we can see it there. So let's just say Nexa 1, 2, 3. So assuming this clicks well, we should see submission successful. So good. We can see our registration is successful. So to verify that this has gone through, you can go back to your DynamoDB table. The one that I copied into the Lambda, was it the Nexa table that I copied into the Lambda, or was it registration table I copied into the Lambda? I can't remember, but we'll check the Nexa table. We'll go to explore items, and great. You can see it here, nexa@gmail.com, Nexa 123. So like that, we have successfully implemented a very simple and basic registration application, which is usually just part of a, like I said, the registration part is just basically this part here going straight to DynamoDB. So like this, we have successfully created a simple and a basic serverless application that runs on AWS Lambda. And to also verify, since it went to the cloud, CloudWatch. So unfortunately, we couldn't set CloudWatch for the Nexa function. So I don't think we'll see it here. But let me just show you here in CloudWatch. You come to logs, logs group, log groups, and we may not see it here because the CloudWatch, the role of the CloudWatch, this thing, okay, didn't come here because we didn't add the row, the CloudWatch full row. But as you can see here in CloudWatch, we can read the logs of what happened. And from here now, you can see the same name, email, phone number, and you know whether it's successful and all that. You can see how much traffic it's used, how much will be billed, and all that. But not to worry, because you have like a free 1 million calls per month for free. So yeah, thank you very much. And if you have any questions, please do ask and I'll try to answer, please. So thank you. Thank you, Kingsley. And thank you.
Thank you so much, Uneku. Really, really appreciate your time, your efforts, and your thorough explanation with our favorite method of learning, hands-on examples. So you've shown us how we create the functions and how we work with them. So on behalf of everyone present and NexaScale Cloud community, thank you very much. Does anyone have any questions for him before we quickly round up? You can stop sharing your screen now. All right. Does anyone have any questions before we proceed to one other shot? Okay, no questions. All right. Before we round up, I would just like to show or demonstrate a little thing from this week's exercise. Let me share my screen. Now, last week, or this week rather, we were to handle this project. Where's my screen? Okay. Okay. So this was our project or our lab for the week: build secure and manage serverless applications at scale. And if you went through this example, you would have at this point been able to build a serverless using SAM, a serverless application model. You would have built a database API gateway with multiple endpoints and lambda functions, right? So with this, each lambda function, the API gateway is associated with a particular lambda function, and API gateway is associated with a particular lambda function, just as he has given or explained in today's class. Now, in going a step further, they now introduced order pooling, where you pull orders from an SQS or an SQS queue. Simple. What's the queue for again? An SQS queue, simple queue service. So when you have events, they can be sent as messages to the queue, and when you're done processing, it leaves the queue. Now, why is the queue important? In a typical API to Lambda to DynamoDB configuration, as he has explained, if for any reason the Lambda function is not working at that point, that request from your API gateway would be returned or would get an error response, and that particular transaction is cancelled. So let's say someone wants to make a payment, a transaction payment, yeah? From the front end, you put in your card details, just as it has in that form. The form sends your card details through API gateway to a Lambda function that will process your transaction. When it's done processing your transaction, the Lambda function can maybe, for example, now say add your name to a particular database. Say, for example, you are paying to subscribe to a group. Yeah, you want to subscribe to a group, or you want to pay for your school fees. You put your card details in the front end. The form sends your data through API gateway to the Lambda function. The Lambda function is meant to process that payment transaction. And if it is successful, right, your status on the database would now be updated from unpaid to paid. This is a simple flow. That Lambda function, after successfully executing payments, would now update using your student ID, which you must have put in from the front end, would now update the database where your ID is and update your status from unpaid to paid. However, if something happens along the way and that Lambda function either has a problem, it could not execute the code in it, it could not receive the message that was sent to it through the API gateway, it then means that transaction you have done is cancelled. You either get a 503 request, a 503 error, a 500 error or something, and you have to repeat it all over again. So as long as that Lambda function is not currently able to process your transactions, you are going to keep repeating that transaction over and over and over and over again. right? However, to mitigate this problem, we have what we call AWS SQS. So all your requests are being sent from API gateway directly to the SQS service, a queue. From that queue, it would now be sent to the Lambda function. If the Lambda function cannot at that point carry out the request or handle it, it is going to now send it to what they call a dead letter queue and save it there. So that whenever the Lambda function can now execute the code or execute its messages, it would now send it back to the Lambda function to execute. So that way, you at the front end are not solely tied to whatever Lambda function is running at the back. The client is not tightly coupled to the Lambda function. All the client needs to do at this point is fill the form, click on send. As long as API gateway has received it and sends it to the queue, we tell the client your request has been received and is being processed. That is all for the client side. SQS would now send that information to the Lambda function. If it executes, fine. If it does not, send it to the dead letter queue. And whenever the Lambda function can carry out its executions, send it back. So let's do a very, very quick explanation of this. Now, if you carry out this example, by now you should have built an API gateway and the Lambda function. First, I will start by creating an order. This is an order for, this is a food order rather. When I create this order or this data is sent to my API gateway in my dev stage and in my orders table, my orders resource, right? Under the post request. This particular resource and this method is sending its information directly to an SNS queue, which is my main queue. So let's see, I want to order Chibuzo. Can you hear me?
Yes, I can hear you.
Yeah, please tell me the name of the food I should order.
Okay, order white rice and coleslaw.
All right.
Yeah.
So how do you spell the end of that? SAW, yeah?
Yeah, I think.
Okay, good. Who is laughing? Kosi, what's the name of the restaurant I should order from? The restaurant ID.
I don't know.
Pick a name, pick a name.
And Passion Restaurant.
Do I just give it an ID or do I just put the full name? Who else is on the call? Chukuma Igbegulam. Please give us the quantity of this white rice and coleslaw we should order.
40 plates.
Ah, nice one, nice one. This guy will throw one bear for all of us today. So we have 40 plates of white rice and coleslaw from Passion Restaurants. Let's make our order. Okay, so I send my request. And this message I get here is from SQS and not from DynamoDB. If you ever worked with DynamoDB, you will know that when they're sending you a request, you're going to see something called metadata, right? That's $ metadata, then other messages, consume capacity and all that jazz. Then if it's return an item, you also see item. So this message is coming from SQS, right? SQS is giving me a status of 200. I, as a programmer, would now use this 200 to tell the client your message or your order has been received, right? Your order has been received. It is being processed because now you no longer have any business with Lambda function. All you need to do is send your request. Now let us see if this order was sent. Passion Restaurant white rice. So I'll move over to my DynamoDB. Where did I open that again? DynamoDB. So let's go search for that order. So this is the order table. Explore table items. It automatically created a what's it called? An ID for us, and this static user is from the code. So let's search for, it's easier to search for passion. Let's see, passion. Oh yeah, here we are. So white rice, quantity 40, passion restaurant, right? And our status is pending, 40 plates. So because the lambda function is healthy, our what's it called? Our message came in from API gateway, passed through this order queue, right? And went to the lambda function. Now we are going to throw in an error in our lambda function. Currently, if we refresh, we see that there are no messages available both for this and for this one. No messages in flight because all of them has been executed. There's only one message you sent. There are no pending messages. This is a dead letter queue. If this guy passes this message, if our main queue passes the message to the lambda function, right? If the lambda function cannot execute that, it discharges that message to the dead letter queue. That is where it stores all messages. So I'm going to modify my lambda function, and I'm going to throw in an error. I'm simply going to say exit. Once you just load the lambda function, exit immediately. So that way our lambda function would not even run. So I'll go back and I'll do my SAM build. Everything here is in the material for this week, in case you do not understand what's going on here. If you just go through the serverless material for this week, everything I'm doing here is there. I'm only just trying to explain the importance of SQS. So I've done my build. I'm going to deploy. No confirm change set. So it's going to deploy everything I have just, it's going to deploy this modification, and it's only going to change my post request. Let me see if I'll get that diagram. Okay, this is how the original diagram is. When the user sends a request to API gateway, it either goes to this lambda function or this one or this one or this one. If any of them fails, you receive an error request, or an error response rather, error 500. However, once we now introduce SQS, when the user sends a request to create an order, it goes into SQS. SQS now sends it to this lambda function, or this lambda function triggers, once it receives a message, it triggers lambda. The lambda now fetches the message it has in here, right? But if for any reason lambda says it cannot get this message, it cannot work with this message, SQS will then dump the message in dead letter queue. You would now configure how you want the message in dead letter queue to be retried. You could use event bridge to check, is there any message here? Every 10 minutes, check if there are messages here, then process them and send them to the lambda function. The lambda function can still not process them at this point, keep them here. They're going to remain here until this lambda function can eventually process them and save them in database. So that's exactly what we're doing. So at this point, yeah, I've successfully updated my lambda function. I would now go back and try to recreate another order. All right, so I need names again. Fatima, are you with us? Okay. Who again is here?
Yes,
Oh, she's here.
Kingsley. What did you say?
Yeah, please tell us the name of the food to order.
Food to order.
Yeah. Well, we created an API for making orders, so we need name of food to order.
Other fried rice.
And
Other fried rice and chicken.
now that's general. That's generic.
You don't want something that is generic.
Today is Saturday. We're eating fried rice and chicken Monday and Wednesday. And yeah, and I don't do swallows, so no swallows.
Oh.
It's something you will eat, too. We're ordering food for you to eat.
Nah.
Okay, you
Okay,
want
so
fried
what
rice
if
and
you
chicken?
order pasta?
Italian pasta, Lekki pasta, mainland pasta, which type?
Trenches pasta.
Ikorodu pasta. All right, let's go. Trenches pasta. Trenches pasta, does it have protein? Or you just
And
just
now
take
it's
pasta like
have
that?
protein like pomo. They'll put pomo there.
Yeah, your mind is there.
Pomo
Your
and
mind
dry
is there.
fish.
Yeah. So then pure water. Pure water should be additional. One or other.
Yes,
The woman is supposed to add it
pure
for us.
water.
Okay, so who's going to give us the name of the booker we're going to collect this one from?
Nari buka.
All right, any suggestions? Yeah. Oh, guy. Yeah, Basira. Is it Bashira or Basira? Yeah, Bashira. I'll always remember this song. Yeah, Bashira, you will kill me. Oh. All right, quantity. I hope my network is still okay. All right. So quantity, how many plates are we ordering from Iyabashira?
Just order to me for me and her.
Okay. Fatima, 2 plates coming up. He will bring the pure water as he's coming. Inside black nylon. 2 pure water in black nylon. So we have quantity 2, name and restaurant. We're going to send a request. Remember, our last request gave us 200. We're sending a request again. Let's see what our request will give us. 200. Successful. They have told the client, Ma, we have collected your request. You can go. Let us process it. Whether the person cooking is having COVID or the person cooking is healthy, what they know is that they have collected your request and they've told you to go and sit and wait, right? What happens in the kitchen now is no longer your business. You are not standing there and waiting for them to prepare your food so that you stand long and you say your leg is paining you. They've taken your order and they've said, Ma, you can go and sit there with Oga. We will bring your food to you. However, let us see what's happening behind the scenes. If we go to our queue and we refresh, you see that for our order queue, we still have 1 message in flight because it is still trying to process the message, right? In the code, there's a section where I set how many times it should retry before it gives up. Where is it? Template of YAML. Yeah, okay, this maximum recount 5. Let me see, did I configure retries or is it using the default retry? Okay, I think it's using the default retry. So there are a certain number of times it's going to attempt to retry to send that message to Lambda. But if Lambda keeps rejecting and saying it cannot, because right now our Lambda function cannot work. I told my Lambda function to exit. Once he has loaded, before it even does anything reasonable, exit, close the function, so you cannot even run. So my queue has received a message and it's still trying to send it to Lambda. Lambda, take Alpha. Somebody has given us an order. Right? Alpha, are you still retrying? Can you do the order? Can you come to work? Can you cook? We can keep doing this. Then after some time, it is now going to move this message from in flight and send it to the dead letter queue. Why? It didn't take so long the last time. Let me try sending multiple requests and see. So all these requests are successfully going through, but they're all being stored in the queue. Okay, I think I've sent about quite a number of requests. So you see, that first message I sent could not be handled by the function. It has dumped it in where? The dead letter queue. The last 5 I sent is still is trying to process it. It's trying to send it to the lambda function. The lambda function is not working. It's not open. Yeah, they've told the girl in the kitchen somebody wants to buy trenches, rice, and pomo. She's saying, the woman, madam, you never paid me last month. I know if you touch that pot. The woman is still trying to beg. I know if you touch that pot. If the girl do the strong head finish, the woman will just carry the order and keep and wait for when somebody will come and do it. That's exactly what is happening here. But the point is that the client has made his request and the client has gone to sit. So there's no need keeping the client waiting. And I know a company I know that does this is well, these guys we pay bills though, PHCN bills. Buy power. I've noticed that with buy power, you can sometimes transactions fail, but even when it shows you it has failed, sometimes after like a couple of minutes, it then pulls through and they tell you, okay, what you're talking and all that. I don't know if it happens all the time anyway, but I noticed that with them. So we can use this in our applications. Yeah, this is example of how you can scale applications with serverless. Sometimes also your database might not be able to take in as much requests as are coming. For example, MySQL, PostgreSQL, those databases are not serverless. So you can have 1 million requests per second coming in through your front end, but these guys, the databases cannot handle. So everything has to go into a queue first. Then the databases can now gently start taking in these requests gradually, so that you don't overwhelm your database that it now shuts down. So these are some of the importance of having or making use of queues. If there's a problem with the function that is supposed to execute it, it does not just throw it away. Rather, it saves it and keeps it in the dead order queue, right? And whenever it can, it would now execute. So let me go and make the correction. So our lambda function can be healthy, and so that the girl in the booker can be paid, maybe for it. So after the modification, I come back and I do SAM build. It modifies my code and only modifies my post resource. The same way you do in CloudFormation. When you create a CloudFormation template, because this basically still converts SAM template to CloudFormation template. If you make any modification in the template, it only modifies that particular resource you've modified in the template file. All right, let me see if I can be refreshing this. So you see the 5 of them has gone immediately. Because I modified the lambda function while it was still trying to send it, right? It has sent the 5 of them to lambda immediately. However, this one that was now pushed to the dead letter queue would now remain here until I've written, let's say, like a code or a trigger to work with this dead letter queue. However, to do it manually, you just click on the dead letter queue. First, let's go and look for Yabashira. Very important. Why are we having just 36? Hold on. Probably he has pushed those things already to the dead letter queue. Oh, he has pushed them here already. So the 6 of them are here. So now we can either do this via code, or you as a backend developer, or even here, you don't need to write code. You can just go to Event Bridge and configure this guy to always send his request to your Lambda function. So periodically, Lambda function will check the dead letter queue. Are they requesting you, right? If you are requesting, all right, send them to me, let me process them. You can program this to happen every 1 hour, every 10 minutes, whatever. So if I come here, I have, I should have my requests here, about 6 of them. Okay, no, this is for redrive. It listed the 6 of them for me. Sorry, hold on. I know it didn't explicitly list them one after the other, but it showed the number of. Okay, yeah, message available 6. So I have 6. So what you do is, if you want to now send all of them to the appropriate Lambda functions, you just come to start DLQ redrive, start dead letter queue redrive. So when you do this now, it now attempts, here we're doing it manually, you now attempt to send all your dead letter messages to the appropriate quarters to be processed. If it still cannot be processed, they will all be sent back. So let's try. Start SLD drive. We drive the source queues, yes. If you want to send back to the queue that sent them here, it was the source queue, the main queue that sent them here. If you want to send them back to that source queue, then you use this. If you have a different Lambda function or a different queue, a different place where you want to send everything that failed to, then you select the second one. But what I want to do, I still want everything to be sent. I still want my orders to be sent down to DynamoDB. So I'm resending it back to the original queue, because that original queue from my configuration is communicating directly with Lambda. So by sending it back to the original queue, it's the same thing as me going back to my endpoint and sending on that request. So once a request hits my main queue, it sends to Lambda. If it does not work, it dumps it to the dead letter. A dead letter wants to send it back, it sends it back to the main queue, and that main queue triggers Lambda function again. So I leave everything as default. I have 6 messages. Then I do my DLQ drive. Everything is successful. Everything has been sent down to the main queue, and the main queue has processed. So I should be getting 42. Okay. So where's Iya Bashira? Yeah, number 1. So we have our trenches, pasta, and pomo. 2 plates with pure water at Iya Bashira. All of them will be here. See them, 6 of them. 1, 2. Did you count them as multiple? No, it should not. Okay, yeah, these are all of them because they all have different IDs. So you see, instead of a request failing just because our backend was having a problem, with SQS, you simply queue up these requests pending when your server or whatever is now working. With this now, we call this being that your architecture is loosely coupled. In a tightly coupled architecture, you have to wait until you get a feedback response from whatever transaction that is happening. But in a loosely coupled system or in an asynchronous system, one side simply does its job and hands off. Any other thing that requires what this guy A has done would now go there. Okay, this guy has finished his job. He has dumped it here. I need this thing. I pick it up and I continue the mount job. That's what these guys do. The front-end API gateway has gotten the request, dumped it to SQS queue, and wash his hand of the matter. Any other person interested in that transaction will go to that queue, pick it up, and use it. And the Lambda function is interested, as we see from this our diagram. This Lambda function is interested in what we have in this queue. We will have other things now. Let's say for all bad requests, you connect on that Lambda function that processes late requests. That will also send an email to the client. So and so, we're sorry for the delay, but it has been processed. You can add that one here too. So this is how you can use AWS serverless architecture in making your code, making your applications loosely coupled. You see, I didn't write any serious code in this case. I only just converted this to this, modified the template file. The only code I wrote are the code inside the Lambda functions. So AWS serverless is awesome. If you've not gone through this, you can please go through the labs and do this for yourself. Yeah, the more you practice, the more you get better at cloud computing. So that's all for the little demonstration. Do I have any questions from the group? No questions. Everyone understood everything perfectly.
Kingsley, sorry, I
Yeah.
would like to. How can I access the resource for these lessons?
Are you new to the group?
Yeah.
Okay.
I joined not too long.
Okay. It's like I was explaining earlier to Chibuzo. We have this AWS Expedition challenge. Let me see. Let me just go to the website at once. So this is the website where it's hosted. Ethereum. Challenge is AWS Expedition. So if you scroll down to week 8 is where you have serverless. So when you click on get started, you will see the stuff. Let me post the link to the chat.
Okay, thank you.
Yeah, you're welcome. Kosi, I'm seeing your waffles and ice cream. So the link to the challenge is in chat. All right. Without further ado, I believe we'll call it a day. Fatima, over to you. Fatima, thank you, Chibuzo. You're welcome. Okay, I think she's busy. All right, guys. Thank you all for joining today's session. I believe we all learned. And thank you, Uneku. Okay, he's gone. For sharing with us. All right. Take care, guys. Do have a lovely weekend.